Hello, so I'm doing a work problem, and to my left is the sketch, and so a force is pulling a block down an incline, so my F1 is my applied force, and my FK, my kinetic friction, is opposing the motion, so it's going to the left. 3 meters to the length of the incline, and theta is the angle. So I made up the mass F1 and the theta, so I got for M 100 kg, F1 4N newtons, theta 30 degrees, your MK, your friction is 0.5, and your displacement is 3, because that's the length of the incline. So next you draw your free body diagram. Your normal force is always going up, your weight is always going straight down, that's your FG. Your F1, your applied force is going the way of the motion, and your kinetic friction is opposing it. So next we want to see which forces are doing work. So first you want to start with N, and N is going to be 0 because it's parallel of the motion. And so next we want to look at FG, and we know that a component of FG will be doing work. So you want to draw your Y and your X. This is your FGY, FGX. And so your FGY will also be 0 because it's also perpendicular to the motion. Next, you want to look at your FGX, and that is parallel to the motion. It's going the same direction. So you want to do WFG equals FGX times your displacement. So that will be WFG times mg, and so since this is opposite of this angle right here, it will be sine of theta times your displacement. So that will be 100 for your mass times 9.8 for g times sine of 30, since that's your angle, times 3, which is your displacement, and I got 1,470. Next, you want to look at your F1. Since it's also parallel and it's going the same motion, that's also going to be doing work. So you want to also give your X's and your Y's, FGY, FGX, and so you want to write it as WF1 equals F1X times your displacement. So this equals F1, your X, this is also an angle of 30 degrees, and since this is beside it, it's cosine of theta times your displacement. So that would be 4, since your F1 is 4, cosine of 30, so that's your angle, times 3, which is your displacement, which is 10.39. Next, you want to look at your friction. Even though it's going the opposite way, it's still doing work. It's going to be negative. So WFK equals negative FK times your displacement. So next, that's negative MK N times your displacement. So since N is not doing work, it still has a force value. So we can find that by doing the sum of Y equals 0. And so N plus F1Y plus FGY equals 0. I chose these values because these are all the values in the Y values. So this is your N is going up, your F1 is going up, and you have a FGY that's going up. So these are all your values that are going up. So this will be N plus F1 sine. Since the Y is opposite of the angle, that is sine of theta plus, and this is cosine because it's beside the angle. So this is mg cosine of theta equals 0. And so I'm going to switch this to the front because it has a bigger value. So N equals mg cosine theta minus F1 sine of theta. So when you put values in it. That's N equals 100 for your mass times 9.8 times cosine of 30 minus 4 sine of 30. And so when you add those all up, your N is 846.7 newtons. So you can put this back into here, and if you add those all up, I got negative 0.5 times 846.7 times 3. And so for my kinetic friction, I got negative 1270.1 joules. And so since you have all your values, all you do is add them up. So it'll be of W equals 0 for your WN. This is your WN. 1470 for your WG plus 10.39, and this is your WF1 plus negative 1270, and that is your kinetic friction. And when you add all these values up, I got 210.29 joules. Thank you.